Alright, so this is our introduction to the sine law, which is the first bit of our trig unit. So, a real quick review. You've got a triangle here, and we're going to label it with A, B, and C like this, or the vertices are labeled. A, B, and C can be whatever, but typically A, B, and C. So if this is vertice C, then this is, or sorry, if that's vertice A, then this is angle A, and this would be angle B, and this would be angle C. And then, if I want to label the sides, side A is the side that's directly across from angle A. So if you want to think about like bisecting the angle and you put a line right through the middle of the angle, the side that line would hit is side A. And that's lowercase a. So then we go around the triangle. Here's angle B, so there's side B. Here's angle C, and here's side C. And notice I just drew any old triangle here. It looks close to a 90, but I had no intention to make it a 90. It's just a regular old triangle that's not a 90-degree triangle. So, keeping that in mind, there's still certain properties of triangles that allow us to find missing sides for a non-right angle triangle. And this sine law is one of them. Okay, and here's the problem. Just right underneath. So there's the basic property. And all it says is that if I put the side length A in ratio to the sine of angle A, and I put the side length B in ratio to the sine of angle B, and I put the side length C in ratio to the sine of angle C, the ratio will be constant in any given triangle. And so this ratio will equal this ratio will equal this ratio. So what that does is allow us to solve for missing sides or missing angles on a non-right angle triangle. So let's do an example to show how this works. Okay. So here's a triangle labeled ABC. I'll quickly write my sine law here again. So there's my sine law. So what I need in order to use the sine law is at least one pair of these where I know both the side length and the angle. Okay. So let's go ahead and label my sides here. This is side A, this is side C, this is side B. Okay. My angles are obvious. Okay. So you might say, well, which one of these do I know both for? Okay. And if you just jump right into it without kind of taking a look at your triangle, you say, well, there's the angle, but I don't have the side. Here I have the angle again, but not the side. And C, I don't have the angle, but I have the side. So you might think, well, I don't have any pair here at all, so I can't solve this one. But if you look at the triangle, inside of the triangle, I've got two of the angles. So that means I can find, right, the last one, because I know there's 180 degrees total in a triangle. So all I have to do is go 180 minus the two angles that I have. Okay, so I've got 140 plus 12 is 152 total already. Okay, so that leaves me with 28 degrees for here. Now I have both angle C and side C. So since that's the pair that I know both for, I know I'm going to be using that ratio, so we'll write that down. And the other ratio that I'm going to use is the one that I'm looking for the missing item, missing side or the missing angle. And so this question's asked for side AC, which is side B. And so that has to be my other ratio. We fill in our information. C is 12. My angle C is 28, so I'll be taking the sine of 28 degrees. And we'll set that equal to B, okay, which is the missing side length. And then sine B, so the sine of 36 degrees. Okay. So now at this point, we're just going to cross multiply to solve for B. Cross multiplication means, this means that I'm going to multiply this by this, and this by this. And so you end up with sine of 28 degrees times B is equal to 12 times the sine 36 degrees. Okay, I'm going to see if my calculator's on. It's not. I'm going to turn that back on. So now we're going to, at this point, you can either bring the sine 28 over to the other side, or you can put the numbers in right away. Either way works. Okay? I kind of like to get all of this information all on one side, so I have B by itself. And so that means I'm going to divide by sine 28 degrees on both sides. And this goes away. So we'll just erase it away. Okay. So I have to go and turn my calculator on my computer for some reason, even if I hit the on button here. It doesn't turn on until I turn it on from my computer. Okay. So, there you go, the calculator's on. And these TIs, a real quick note, you have to go into the mode button and make sure you're in degrees, or else this calculator won't do proper calculations. It's the same with if you're not using a TI, and you're using regular, let's say a regular store-bought calculator, make sure it says degrees at the top and not radians. Okay, so mine's already in degrees. Okay. So now I'm going to do this calculation. Okay. So I'll do the top first. So I go 12 times the sine of 36 degrees. Hit enter. Then I'm going to divide that by the sine of 28. And hit enter, and I get 15.0. Okay. So there's my solution. And we'll just take a quick peek up at my triangle, see if that makes sense to my diagram. Okay. This is 12. This side should be probably somewhere in the same order of magnitude. Okay. So 15 does make sense. I would know if I got, say, 100 or even 50 that I probably don't have. I've done something wrong, but this fits in my triangle. So let's do another example here. Well, that one's looking for a side, so maybe we'll stop there. I'll put another video up where I solve for the angle rather than the side. It's the same exact calculation. Okay. Really quickly, what I'll do is I'll simulate saying I get to the end of the problem, and you've solved it, and you have sine B equals, and you'll have some type of decimal, say 0.742, something like that. Right? And you'll get down to there. The very first time you do one of these calculations, and you solve for it and say there's sine B, you say, well, that angle's way too small. Right? That doesn't seem to make sense. Well, what you have is not angle B, but the sine of angle B. Okay? And I don't want the sine of angle B, I want the actual angle B. Okay? So, what you can do with your calculators is on here, you have what's called the inverse sine. And that's where your calculator says, well, if you know what the ratio is of your opposite to your hypotenuse, or what the sine of your angle is, in this case I do know what the sine of my angle is, the calculator will tell you what angle gives you that ratio or that result. So the inverse sine is almost always right above the actual sine function on just about any calculator. So here I have to go second function inverse sine. You put in your 0.742. Close the bracket, hit enter, and it tells me that was a 48-degree angle. So then you can say B is equal to 48 degrees. So angle B equals 48 degrees. So that's just a real quick demo if instead you're solving for the angle rather than the side. So that's your basic sine law.